We've reviewed the templates and we're almost ready to deploy our web application. Before we get started, please make sure you haven't reached your service limit for the number of VPCs. If you have hit your limit, make sure you delete one of your unused VPCs before proceeding. In this demo, we're going to deploy the appstack.json template. To make it easier for you to follow along, the commands we'll use are in the exercise files in a text file named aws-cli-commands.txt. Please load that file up in your favorite text editor and let's go to the command line. The AWS CLI can validate your CloudFormation templates to catch formatting and other errors. Validating your template before trying to deploy from it can save you a lot of time and trouble. So we'll start by checking the app stack template, and we can do that with the CloudFormation validate-template command. Let's go ahead and run this. If there are any errors, it is going to tell us. If everything is good, it is just going to show us the parameters. So in this case, we see the parameters, so we know that everything validated well. Next, let's check the network stack template. Go down one line here and we'll run this. Awesome. No problems here either. Now, recall that the app stack template is going to look for the network stack template in my S3 bucket. I've already loaded the network stack template to my bucket, and if I had not done so, then I would just go ahead and run this AWS S3 copy command. Finally, the moment you've been waiting for, it is time to deploy the application stack. We'll reference the local appstack.json file, and I will name the stack app-stack. Are you ready? All right, let's go ahead and execute this. The AWS CLI will sit here for a while until CloudFormation has finished building the stack. This normally takes about 10 minutes, give or take, so if you're following along with me, you may want to pause the video until the stack is created. Once the stack is created, you should see this message, successfully created stack app-stack. Now, to get the URL of the web tier load balancer, we'll execute the AWS CloudFormation describe-stacks command. We have the network stack, which is a nested stack created by the parent stack, scrolling down a little bit, which is app stack. All right, so far, so good. Let's scroll all the way to the bottom. About 12 lines up, we see the URL for the internet-facing load balancer. Go ahead and browse to this URL. I'm on a PC, so I'm going to do a control-click to open this. Remember that we assigned that TLS certificate to the load balancer. My certificate is only valid for coastalcarolinanetworks.com and its subdomains. But here I'm browsing to the URL of the load balancer, and that domain name does not match the name on the certificate. This is totally normal behavior, but it's not the desired behavior, so later on I will show you exactly how to prevent this error. For now, we just want to be sure that our application is working. I'm going to go ahead and click Advanced, and then Proceed. And this is our simple sample application. Under web server information, it shows information about the web tier instance we're connected to. The web tier load balancer proxied us to this instance. This one has an IP address of 10.01.210, which is in Zone A. The protocol is HTTP and the TCP port is 80. To get a better idea of what's going on, let's look at the diagram again. We connected to the internet-facing load balancer securely using HTTPS. The load balancer then connected to the instance via HTTP on TCP port 80. That's why it shows HTTP here. By the way, please ignore the container host name in the container IPv4 address. What we care about here is the EC2 host name. Under app server information, we can see info on the app tier server that the web tier instance connected to. In this case, it's 10.0.101.148, and it is in Zone US East 1A. Specifically, the web tier instance connected to the internal app tier load balancer, and the load balancer in turn connected to this application tier instance. All right, I realize that's a lot to process, and it can take some time to wrap your head around all this, but stick with me and it will start to click. Finally, up at the top, we have the client information. Who's the client? You might think, well, it's my computer. And it is in one sense, but it's actually showing the internal IP of the internet-facing load balancer. The X forwarded for is my public IP address. So from the application's point of view, the client is really the internet-facing load balancer because it's the one actually connecting to the instance. Practically, however, My computer is the client. At any rate, everything is working as it should. Let's jump back over to our command line. If you want to continue playing around with the stack, by all means, go for it. Feel free to pause the video and spend some time experimenting. In fact, I'm going to test out autoscaling by terminating some instances and letting it recreate them so you can see how that process works. We'll do an AWS autoscaling describe autoscaling instances command, and we want to locate both web server group instances. So here we have one instance in the web server group. I'm going to go ahead and copy this instance ID here and set it aside. And if we scroll down here, there's one in the app server group, and we're looking for the other one in the web server group, and there it is. Go ahead and copy this. Now, what we want to do is terminate both of them. To terminate them, I'm going to paste both instance IDs into this command right here, the AWS EC2 terminate instances command, and I'm going to go ahead and execute this. Notice that the instance IDs are separated by a space, not by a comma. So we can see here this one is in a shutting down state. Scroll down a little bit. The other one is also in a shutting down state, so it is terminating both of them. Now let's run the describe autoscaling instances command again. Notice that we have two new web tier instances with different IDs. We've got this one here that ends in EB2, and then another one that ends in 684. Notice that those IDs do not match the IDs that we had previously. Based on this, we can conclude that autoscaling is working and that it is going to ensure we always have that minimum number of 2 instances.